Our goal is to analyze the convergence and divergence of the following sequence. You have 2 plus n cubed divided by 1 plus 2n cubed. To analyze convergence and divergence of a sequence, we only need to take the limit. Find the limit at infinity if the limit is a unique number, then the sequence is convergent. So the limit of this function as n goes to infinity is limit of 2 plus n cubed divided by 1 plus 2n cubed, which is nothing but, intuitively you can say that, hey, on the numerator, n cubed goes to infinity much faster than 2. On the denominator, 2n cubed goes to infinity much faster than 1. So you can simplify this into 1 divided by 2. Since the limit is a unique numerical value, you say that, hey, this sequence is a convergent sequence. Since the limit exists and it is unique number, so our sequence is a convergent sequence. Take a look at this guy here. The next one that we want to discuss is basically the following function. I give you the sequence of cosine of n pi divided by 2. The same argument. We find the limit at infinity. If the limit is a unique number, then you say that the sequence is a convergent sequence. So let us find the limit as n goes to infinity. Remember the behavior of cosine function. Cosine of n pi divided by 2. When it comes to cosine of n pi divided by 2, if n is odd, you end up with 0. So from pre-calculus, recall that when n is odd, then the cosine of n pi divided by 2 is nothing but 0. So this is your very first case. N is an odd number, cosine becomes 0. However, when n is even, you end up with plus minus 1. When n is an even number, then cosine of n pi divided by 2 might be positive 1 or negative 1, depending on what is the value for n. So what does it tell me? It tells me this function is oscillating between -1, 0, and 1. So this function takes on 3 different values. And when we take the limit, as n goes to infinity, we have no idea which value is it diverging to or converging to. So eventually you say that it's a divergent, is converging to. So our conclusion is that the sequence or this function is a divergent sequence. So for any sequence, you need to find the limit at infinity. For some functions, like absolute value functions or trig functions, first stop, think about them, remember the behavior of sine, cosine, tangent, arc, or inverse trig functions, absolute value functions, then decide about the limit at infinity. So for example, for cosine of n pi divided by 2, depending on the value of n, if n is odd, cosine of n pi divided by 2 is always 0. However, when n is even, cosine of n pi divided by 2 oscillates between +1, -1. So your y values are 3 different values. When n goes to infinity, we have no idea which value the y or the function converges to. So in general, you're going to say that, hey, you have a divergent sequence.